national journals as well as conferences. In addition to this, he has conducted various trainings, seminars, and workshops on subjects like C++ programming, PLC programming, designing using AVR microcontroller, ARM Cortex-based designing, and Internet of Things. He has delivered many expert talks on various topics, some of which includes MATLAB in engineering, Internet of Things, and MicroPython. He has guided more than 100 masters and PhD students. Now moving on to the profile of our next expert, that is Professor Puneet Lathia. Professor Puneet Lathia is presently working as an assistant professor in EC department, Government Engineering College, Rajkot. He has passed his graduation and post-graduation with distinction from VVP Engineering College, Rajkot and Viswakarma Government Engineering College, respectively. He has 9 years of academic experience in various institutes like VVP Engineering College, RK University, and GEC Rajkot. He has 1 year of working experience at eInfochips. He has delivered many expert lectures on various topics like modern digital design using VHDL, LabVIEW training Core 1 and Core 2, and VLSI system design. In addition to this, he has received certifications of CLAD and Advanced Postgraduate Diploma VLSI Design. Professor Puneet Lathia is gold medalist in his post-graduation degree in signal processing and VLSI technology. He has also won many national level technical competitions. Professor Puneet Lathia will be delivering the hands-on session along with Dr. C.H. Vitlani. Again, along with this, I need to give some important instruction to all the participants. The first instruction is that please make sure that you are having 80% of participation and you are scoring 60% of marks in all the quiz which are given to you either during the session or after the session. Secondly, please keep your microphone muted during the session so that experts can deliver their session at the best. At the time of question answer session, you can unmute your mic and you can ask the questions. You can also post your questions in the chat box. And the attendance will be automatically fetched from the Microsoft team. So please make sure that you are attending the sessions for 80% of participation. I end my introduction over here. I request Dr. C.H. Vitlani to take over the session.
Thank you very much. Thank you very much, madam, for introducing me and Professor Puneet Lathia. Now we will start our session. I will share my screen first. And just give me, madam, just give me the feedback then after that whether my screen is visible and am I properly audible or not.
Yes, sir. You are properly audible and screen is also visible, sir.
Screen is also there. Okay, thank you. Thank you very much. So welcome all the participants in session 5.
Yes, sir. You are audible.
I am audible? No?
Yes, sir. Yes, sir.
Okay, fine. Thank you. Thank you. So in this session, we will be doing the Node MCU programming. We will be interfacing digital device, analog devices with the Node MCU. We will control the devices through Bluetooth link, Wi-Fi link. We will read the sensor data and we will upload it in the cloud. So Node MCU, many of you have already purchased and some of you are already having in the labs with you. So this board is a very low cost device which is having a microcontroller inside it. Along with the microcontroller, it has inbuilt Wi-Fi chip. Madam, my next slide is visible or only first slide is visible?
No, sir, it is visible. Node MCU.
Visible. Next
It
slide
is
is also
visible.
visible. Fine, fine. That
Yes,
means
sir.
I am able to change my slides. That is okay.
Yes, sir.
So in between, if there is any issue, please let me know. If my audio is not proper, if screen is not visible, please give me feedback, right? So it has a Wi-Fi support of 802.11 and 2.4 gigahertz is a license-free band available. On that frequency it is working. It has one analog input, so 10-bit ADC is integrated with the node MCU. It has 13 digital IO pins. And all these IO pins are also having a alternate functions, like some of the pins will work as a UART, some of the pin will work as a inter-integrated circuit. So yesterday Kamdar sir described about few sensors which was having a I2C interface, inter-integrated circuit interface, was having a serial clock, serial data in that. It has also SPI, that is the master output slave input, that is MOSI, and MISO, master input slave output. Then UART means universal synchronous asynchronous receive transmit. So all these alternate functions are there in these digital pins. It has a USB micro USB port which is available here, as you can see in this diagram of this node MCU. This is a micro USB port. This is antenna for Wi-Fi chip. This itself is the ESP8266 Wi-Fi chip, and there is a controller here available. And these are the connectors where you will be able to connect the IO devices. And it supports MicroPython programming as well as Arduino programming. So today we will discuss Arduino programming. Tomorrow we will discuss MicroPython, how to upload the MicroPython firmware in this node MCU board, and then how to write MicroPython program for this board. Today we will be uploading our program using Arduino IDE. This is a pin diagram of node MCU. It is already available with you because I have shared this material yesterday through WhatsApp group, through Google Classroom, as well as through Microsoft Teams. So that material is already available with you, which you can refer later on also. So what I was talking was digital pins are available like this from D0 to D4 here. Then after there is a 3.3 volt pin and ground pin. Then after D5 to D10 pin. And all alternate functions are shown here. This pin number D3 is a GPIO 0. This D4 is GPIO 2. But at the same time, it is also a serial port 1. So it is a transmission pin of serial port 1. Then on this side after D10 there is a ground and 3.3 volt. More number of supply pin and ground pin is given so that you can directly connect the sensors with the node MCU without need of any breadboard or any PCB. If you have 1 or 2 sensors, you can directly connect. If you are having a more number of sensors and more number of devices, then you may need one more PCB or a breadboard to connect with this. On this side, there is a 5 volt pin. So whenever you require a 5 volt, you can connect it here. Ground, reset pin, enable pin. Again, 3.3 volt and ground is given here. SCK is a serial clock. This MOSI and MISO is for SPI communication purpose, serial peripheral interface purpose. D11 to D12 is again GPIO pins available with us. And this is one analog input pin. So node MCU is having only one analog input. That is the drawback of node MCU. If you look at ESP32, that is the latest version of node MCU. Node MCU is costing around 250 rupees to 300 rupees. ESP32 is costing around 450 rupees, but it has more number of analog channels. If you want to connect more sensors, then more channels are provided in ESP32. Another advantage of ESP32 is that it has a Bluetooth chip in it. So this node MCU is having only Wi-Fi chip. It doesn't have any Bluetooth. We have to connect Bluetooth externally. That I am going to show you during the hands-on session. But if you purchase the ESP32, then you don't require to interface the Bluetooth module with it. It is having an inbuilt Bluetooth module inside that. We will be using Arduino IDE to program the Node MCU. The Arduino IDE is open source hardware and software. Arduino boards are also coming, so it is also a hardware. Arduino board along with the Wi-Fi chip is also coming, so that you can use it for the Internet of Things. Which means everything about it is freely available on the internet, and it can be shared and modified and enjoyed worldwide. So you can share the material, without any fear of violation of intellectual property. You are encouraged to improve the code as well as hardware and share with others. So it is open source, so all these flexibilities we are getting. There are large number of well-wishers are there. You will find a lot of help on the internet. And one more is in no price of intellectual property. That is the biggest advantage of this IDE in hardware. These are the different boards. Yesterday also I shown you these boards. This is Arduino board which it can be programmed with help of Arduino IDE. It has a Wi-Fi chip which we can use for the Internet of Things application. This is the Arduino Nano board along with the Wi-Fi chip, which also we can use for the IoT purpose. Then this is the Arduino Yun board, and this is the Arduino Mega board. So if you have a large number of IO devices, you can select the Arduino Mega board. Now sometimes Arduino Mega board, Arduino Uno board doesn't have a Wi-Fi chip inside it. And suppose if you do not have a Node MCU, but you have a Arduino, then you can simply purchase a small module like this. This is a ESP8266 module, which operates on 3.3 volt. Arduino operates on 5 volt. So that's why the voltage divider is framed here to reduce the voltage. So this transmission pin of Arduino is connected to the receiver pin of ESP8266. And in the same way, we can say that transmission pin of ESP8266 is connected to the receiver pin of the Arduino. Here we are using pin number 2 and 3 as a serial port. So we are using basically here a virtual serial port. So what it requires, VCC, ground, transmission and reception pins. So this ESP8266 also you can connect with the Arduino board and you can use it. But all these connections you require. But if you have a Node MCU, then all these connections are not required and you will be able to program it directly with help of a Arduino IDE. So, but in a Node MCU, you have to install, some libraries and boards. So simply, whenever you download the Arduino platform from the net, it will not work for the Node MCU. So for the Node MCU, you require some extra steps. So first you have to open the Arduino IDE. You have to go to Files and Preferences, and in the Preference window, you have to press, paste this particular URL. I will open my Arduino platform and then I will show it there also, so that you get exactly idea what I am saying. Madam, is my Arduino screen is visible at present? Just I need feedback from either Madam or Jay Pandya sir. This Arduino ID is visible or not? Or if any participants can unmute and give me feedback, or just write in a chat session whether it is available or not. Okay, I got answer. It is available on the screen. Fine, thank you. So in this actually you have to open the this preferences. And in this preference window, there is an additional board manager URL where you have to paste that line. Otherwise, you will not be able to add the Node MCU in your Arduino IDE. So this is a very important step. Many of our students are, wondering here. They say that, sir, we could not install the. Okay, I will minimize my floating window. Somebody is saying, okay, good. So this is how you have to copy and paste link here. I have already shared material with you, so you will also get the link from that material and you can just copy and paste it here. So this is one step you require. After doing this step, another step you require is you go to this tools and you will find that I have selected here port COM8 and board node MCU. But this board node MCU is available in this list because I have installed it. I have added it in the board manager. So what you have to do, you have to go to board and then board manager. And in this board manager, what you have to do is you have to write either node MCU or you have to write ESP8266. So for example, I am writing here ESP8266. Now it says me that ESP8266 is already installed. If it is not installed in your system, what you can do, you will get here one install button. Just you have to click on that button and this board will be installed for your Arduino IDE. So this step is also required because by default node MCU is not a part of Arduino IDE, so you require to add extra board into the IDE. Let me go back to my presentation. Okay, so what you have to do, you have to go to tools and board manager and then write ESP8266 in the search box and then you have to install it. So these are the steps required before you use the node MCU with the Arduino IDE. The very important functions of Arduino for a minimal program is one is a setup where we set up all the pins which we are using for our application. And this loop is actually a while one loop, this infinite loop, which will run continuously. If you are, all of you must be familiar with a C programming where there is a while one. In a while, if you in a bracket, if you write one, it is become an infinite loop. So this loop is nothing but an infinite loop which will repeat continuously. So if you switch on the power supply of your node MCU, then it starts running the program. And it will remain on continuously until you power off it again. So all the embedded systems are designed like that. All the embedded systems are having a infinite loop in that. It will run 24/7 until you switch off the device. This is a typical hello world program for a node MCU. If you want to check your node MCU, this is a typical program which you can use to check your node MCU. So LED blinking is our hello world program for a hardware. In a software, we normally write the hello world program, like we print initially hello world and then we print if we are getting the output, we say that, okay, my program is working. So in case of a hardware, actually we write a hello world program by blinking a LED. So in a node MCU, there is a LED is connected already, one internal LED is there with the GPIO2 pin, which is actually pin number D4 on the board. GPIO2 means D4 if you look at the pin diagram. So where already we have internal LEDs connected and we want to switch on and off that LED. Turn on and off that LED at certain time interval. So that LED is output device. So that LED pin, we say that pin mode is LED pin comma output. So our pin mode we set is output pin. Then let me change the color of my pen so that it will be okay. So digital write is a very simple, it says that on that particular pin I want to send logic high signal. Logic high means plus 5 volt if I am using Arduino and 3.3 volt if I am using the node MCU. Then delay of 1000 milliseconds, so 1 second delay. Then after we say that LED pin comma low, so that on that pin we are sending active low signal, so LED will turn off. So simply it will blink LED at the 1 second interval. So those who are having a node MCU, later on after completion of today's program, you can start at your workplace or at home, try to run this program to check your node MCU. Then read sensor data. Now, in previous program, we have seen how to control the devices. When we control the devices, whenever we control the LED, we will be able to control the devices, because ultimately in a digital hardware, we are sending logic 1 and logic 0. So by sending logic 1, we glow the LED. In the same way, if you connect their relay board, you will be able to energize the relay and you will be able to switch on and off the electrical devices. That relay can be electromechanical relay or it can be solid state relay. As Kamdar sir yesterday told that people are nowadays not using electromagnetic relay because the life of electromagnetic relay is less because of the mechanical moving part. Nowadays people are using the solid state relay, which is having more life compared to the electromagnetic relay. Read sensor data, in that we will be using analog input. So in analog input, A0 pin we will use. So we have given that light pin equal to 0, device equal to 4. So device connected at GPIO of 4. So device equal to 4 is written. So whatever the device you want to control, it is connected at device number, pin number 4, GPIO of 4. Then in setup, actually what we do, pin mode device output. One more thing I forgot here, because not forgot, because this is the analog input. So by default A0 is already it's initialized, so it's not required to declare here as an input. But suppose some of the pins, if you want to use as an input pin, then those pin you have to write here separate command, pin mode, and that pin number, comma, input. But here we are not using any input pin, we are only using the analog input pin. So that's why we have declared initialize only one pin, that is a device pin. Now inside loop, what we do, light data is equal to analog read light pin. So we are reading the light pin data. Then we print it serially. If light data is greater than 500, we want to make the device on. If it is less than 500, we will make the device low. So at present, I am not demonstrating this program, but more complex program I will demonstrate. In that program, what we will do, we will upload this LDR data on the cloud, and then simultaneously we will operate the device based on the analog output coming from the LDR. So that program I think I will demonstrate. So that will be a big program. So this program will be a part of that program. So it will automatically come in that program. So I am separately not executing this program on my local Node MCU board. So this is actually one more thing which we can use to control the devices with help of a Node MCU. We have a smartphone where application is installed in that, and this application file I have shared with you through Google Classroom, as well as it is available in file sections of our MS Team. So you can just copy in your mobile phone and you can just install it. Unfortunately, it is only for Android. It will not work for iOS because I have written it only for the Android phone. But there may be some ready-made applications available for other platform also, but I have written it for Android phone. Then this is a Bluetooth module which I am using, so that this Bluetooth module will receive a signal from my smartphone, and it will communicate this signal to the Node MCU. Some noise is coming, so I will mute all the participants and we'll start again. Participants are requested to mute yourself so that we can. We will have a question and answer session at the end, so you will be able to unmute your mic and ask the questions. But at present, please listen. So whenever you will unmute yourself, a lot of noise will come in between, and that will disturb other participants. Prakti madam, my voice is clear?
Yes, sir, it is clear.
Okay. Even for you, the same instruction. Whenever you give the answer, then after you unmute your mute your microphone, right? so that
Yeah,
other
yes.
noise will not come. Okay.
Yes, sir.
Okay. Now this Bluetooth RX receive data is this yellow line is connected to TXD0 of our node MCU. So alternate function of GPIO1 is a TXD0. So it has many UART. So UART 0 I am using here. Right? This is UART 0. Similarly, UART 2 is available. UART 1 is available. I am using UART 0 to connect the Bluetooth module. The TXD, that is a transmit data pin of this Bluetooth, its green line is connected to RXD, that is a receive pin or in a node MCU. So we require a cross connection. TX transmission pin of Bluetooth should be connected with a receive data pin of node MCU, and vice versa. Receive pin of Bluetooth module should be connected with the transmit pin of the node MCU. So it is a cross kind of a connection. Then one more you require is a VCC and ground. So these four wires you require to interface the Bluetooth module with the node MCU. If you have a ESP32, then you don't require this module, because in ESP32 there is an inbuilt Bluetooth module is available, right? So this is how I have connected my node MCU with the Bluetooth. I will show you by switching on my camera. Okay, is this Bluetooth module is visible to all of you? An LED is blinking.
Yes, sir, it is visible.
It's visible, na Bluetooth module. Okay. So these are the four wires I have connected with a node MCU. This is the node MCU board, and this is a USB connector I have connected with the node MCU board. And this USB cable I am connecting with my laptop so that I can upload my program. And I have also connected one LED here, right? So all the things I have put under the camera so that whenever required I can show it to you, right? Everything is there. Okay. Now just I will minimize the camera and discuss the program again. Right, this is our setup. What I will do, I will show you the Arduino program first, and then I will upload it into the board. So this is actually a Arduino program. Just tell me whether it's visible on the screen or not. Okay, it's visible. Fine. I got the answer in the chat section. Green is equal to 12, blue is equal to 4, and red is equal to 5. The meaning is that I have connected three LEDs: green LED, blue LED, and red LED with pin number 12, 4, and 5. These are the GPIO pins. 12 means GPIO 12, which is the pin actually on the board. It is a D6. So there is a difference between the pin numbers. GPIO is a 12, but pin is a D6. GPIO is 4, but pin is D2. GPIO is 5, pin is D1. GPIO is 2, and pin is D4, and so on. Right. So this is actually our internal LED, which is available inside the board. So I am showing you at present LED. You can always connect any electrical devices, because these are the only control signals which you will be giving to the relay board. Right. So you will be able to connect any devices there. So this is useful particularly for a home automation purpose. In this setup, I am saying that serial.begin 9600. That means I am sending my data to the Bluetooth, and Bluetooth is working on the serial communication, and in that I am using 9600 baud rate. Pin mode, all four LEDs in fact are defined as an output pins. So this is the pin mode how I am defining. Initially I am making all these LEDs off, so all are low. Internal LED is somewhat common anode connected, so I am sending high, so initially it will also off. Inside the for loop, I am waiting for a Bluetooth command, and I am receiving the Bluetooth data through this function serial.read. It will give me the data transmitted from the smartphone. And whenever my data is R, I want to glow the red LED. Whenever my data is G, I want to glow the green LED and I want to turn on remaining 2 LEDs. Whenever data is a B, that is for blue, I want to turn on the blue LED. Whenever data is a Y, that means yellow, that means I want to glow red and green both simultaneously. Similarly, you can extend it for cyan and magenta for a different combination of red and blue and green and blue. Then this is for internal LED where whenever I will be receiving the command capital L, I will toggle the status of LED. That means if my initial status is 0, I would like to make it 1, and if initially it is a 1, then I would like to make it 0. There are few questions are there in the chat box, but I will read all that at the end of the lecture and then I will answer you. Okay. So this is our program, and I will show you the working of this program in a board. So again, I will turn on my camera. Okay. I will also turn on my mobile phone so that you get exactly the idea. Whenever you will install that application, the application will look like this. As you can see here in my mobile phone, is it visible to all of you? Waiting for connection.
Sir.
It's visible. Fine. Good. So at present Bluetooth connection is not there. So what I am doing, I am clicking on the Bluetooth button. So now it shows me now 2 Bluetooth devices are there. So at present my Bluetooth device is first one 98D33130 and CHV is written. So I will click on that. When I will click on that, you can see that here connected message will come. GEC Rajkot AC department, just below it a very small blue color letter connected is there. That means my Bluetooth device is connected with the Bluetooth module. So my phone is now connected with the Bluetooth module. Whenever I will press red, the red LED will glow. I will show you LED also here. The color may not be perfectly visible to you. Blue color. So you can see the color is changing in the LED. So locally I can see the blue color, but because of the resolution of camera, you may not be able to exactly perceive the color. Similarly, I press on the green color, the green LED will glow. So blue, red, and all that will be there. I will also show you this internal LED of Node MCU. At present it is off. Whenever I will click on the LED button here, you can see that the LED is glowing, right? So I am putting both the things together here. Again, I am pressing the LED button. This is becoming off. So it is actually toggling. Whenever I press again, it will turn on. When I will touch again, it will turn off. So it is kind of a toggling action you will get with help of it. So this is how you can connect your smartphone with a Node MCU through Bluetooth link. And within a home, if your Bluetooth will work for a short distance. So here we are not using any internet, we are not using any kind of a cloud. It's just a local connections which we are using. We can't say that this is a IoT because we are not taking help of any internet. We are not uploading our data on internet. We are not using any cloud. We will not be able to control our devices from anywhere from the world. So that's why we can't say that this is a IoT. But this is local, we can say wireless home automation, or simply we can say it is an embedded system which we can use for home automation purpose. So this is what I wanted to show through the Bluetooth link. Now let me switch over to another thing, that is using a Wi-Fi link. Suppose if you want to control a device and if you have a Wi-Fi, local Wi-Fi available with you, then I will show you another program. Now I think I will remove the Bluetooth module because I don't require any Bluetooth module. Bluetooth module was required only in case of a Bluetooth connection. But now I am going to use the Wi-Fi, so I will remove Bluetooth module from my node MCU. Right, so our link will be only a Wi-Fi link. So this symbol shows the Wi-Fi link. So I will show you initially the program, and then after I will upload that program into node MCU and I will show you that. So let me open that program. I have also uploaded that program in a Google Classroom as well as on Microsoft Teams file section. Now I will first of all explain this program, and then we'll discuss it. I will upload it into the Bluetooth module, and then let me switch off my phone, otherwise it will disturb in between. Okay. So ESP8266 Wi-Fi.h header file you require to install. SSID in my case is India and password is APEC2004. In your case, you can replace this your SSID of your Wi-Fi hotspot and password. You can also use your mobile as a hotspot. Then these are the devices. I have kept the same connections here. This I have already explained in previous program. The same thing, you are declaring this pin as an output pin. Initially, we are making all the devices off. Then we are using connect Wi-Fi function, so it will allow us to connect with the Wi-Fi. And whenever the server is available, it will accept the different commands, right? Red on, red off, green on, green off. All these commands it will be able to accept. So at present, what I will do, I will connect my node MCU with this, as well as I want to connect my mobile phone also with the same Wi-Fi. So first of all, I will upload this program, and to upload this program, what I require to do is that I will check where actually my port is there, COM8 is there, and then I will upload my program there. So it is actually compiling this program, and then it is uploading that program in that. Meanwhile, I will connect my smartphone also with Wi-Fi network, so that both can communicate together. So at present, it is compiling this particular program. Once compilation is over, it will be uploaded. The binary file will be uploaded in the node MCU board. So now at present, you can see writing process is shown here. So it is writing inside the flash memory available in the node MCU. So your program code will reside inside that particular memory. Once it is uploaded, it will also display here. So it shows that Wi-Fi connected node MCU local IP is 192.168.1.104. So this IP we can use to control the devices connected with node MCU. So this same IP address you have to use to control the devices. So I will again switch on my camera, and then we'll show you that demonstration. Now I have removed the Bluetooth module. As you can see here, I have removed the Bluetooth module, and only LED and this node MCU is there, right? I have my mobile in which this application I am running, and I have entered this IP address here 192.168.1.104, and then press the OK. So now my mobile phone is connected with the node MCU board. I will press here red off, then switch LED will become off. Let me show you that LED only. Then red on, that means LED will become on. I will press on green red off, then LED will be off. Green on, so green LED will be on. Green off means green LED will become off. Blue on means blue LED will become on, blue off means blue LED will become off. So simultaneously I can control all these devices with help of all these buttons. Similarly, this test LED, that is for internal LED of node MCU, which I will show you, that whenever we will press on that button, the LED will glow. You can see now logic is reverse. Whenever I will click on off, it will become on, and whenever I will click on, it will become off, because internal LED has common anode connection. That means anode is connected with a plus 5 volt, cathode is connected with a node MCU pin. So whenever we are sending a low signal, the LED will glow. Whenever we will send a high signal, LED will be off. And that's why whenever I am saying the off, that means I am sending logic 0 signal and LED is turning on, right? So this is how actually you will be able to use. If you have a campus wide area network, then within campus, if you want to do a controlling, you can use this type of connections. You will also get the messages here whenever you will press the red off and all that commands. You will also find here, it is also serially coming here. It is sending to Wi-Fi as well as it is also coming here, as you can see on the screen. Is it visible on the screen? On a serial monitor? Prapti madam or Jay Pandya sir, can you just give me the feedback? Okay, I am getting through chat box.
Yes,
yes,
sir.
It is visible. Okay, fine.
Yes, sir.
All right. So this is how we are getting locally also these messages, because we have written that in our program. Inside the program we have written serial print line command. So that's why whatever the command we are sending, that the same command are also available serially through the local serial monitor. So this is actually a program it is already there in the team as well as in Google Classroom. You can try yourself. You can change the number of pins. Instead of LED, you can connect any electrical devices through solid state relay. Okay, so this was using a smartphone for a device control using a node MCU through Wi-Fi link. So this is also not a IoT, because again we are not using any internet for this purpose. Even without internet we can do it. We have a local Wi-Fi hotspot which do not have any internet data. Then also you will be able to use this. So still this is not a IoT, right? The Bluetooth connection is not a IoT. Wi-Fi simple connection is also not a IoT. What IoT is that you will be able to control anywhere from the world. That is actually IoT. So this is what is actually what I have just shown to you. The same thing here. We have connected 3-color LED and then we have controlled it, and internal LED we have controlled it. Similarly, you can also increase the number of buttons here and number of devices which you can connect to the node MCU. Now, the second thing what I am going to demonstrate is the device control using web app. You can also use web app. If you do not want to use the mobile application, you can control the devices through the web app. I have also uploaded this program again in both Google Classroom as well as in Team. So I will upload this new program into the board and then I will show you that. So let me open that program. So this is the program for this. Again, I am using the same SSID and password. In your case, you have to replace this with your SSID and your password. We are using 80 port number. Baud rate we are using 115200 for local reception and transmission. Pins which we are using is 12, 4, 5 and 2. And this is how it will connect to the Wi-Fi network. And once it is connected, it will display the message that it is connected. And it will also display at what IP address it is connected. So that things you will get locally here. And this is simply, you know, what we are doing here. We are getting the messages like light on, light off. These are the messages or a request we will put. Fan on, fan off, air conditioner on, air conditioner off, electric motor on, electric motor off, and so on. So many devices may be there, so you can just extend this list here. And this is actually HTML code which will be running in a Node MCU, and it will be continuously broadcasted. So now here our Node MCU will work as a server. So I will upload this program first and then we will demonstrate it. So now at present it has compiled the program and now it is uploading this program into the Node MCU board. And once it is uploaded, you can just view it on which port it has connected. Now you can see that this port is used to connect the Node MCU. Now again I will switch on my camera and will show you the so on my mobile phone I have entered that same IP 192.168.1.104 and I am getting this entire screen. You can see the light turn on off. So in that case I am not using any mobile app, just I have opened the browser and entered the IP address and I am getting all the status here. You can also use laptop or desktop and you will be able to do the same thing. You can see I can turn on and off devices with help of this GUI. If you can see this LED here, I am making devices on and off. Different colors will be there. Internal LEDs also I can make on and off, so and so on. So this is actually web page we are getting to control the devices. And if you enter this program, so actually this web page is being broadcasted